I was one of the enthusiasts Robert told you about, and I jumped into the DevOps world without thinking too much. Okay, so what I've tried to do together with my colleagues was to implement a deployment pipeline in order to do the continuous integration as the logical conclusion. Everything automated up to the deployment to the server. According to the continuous delivery book, the deployment pipeline is an abstract automated manifestation of your process for getting the software from the versioning system into the hands of the users. This means that once you have the code in the versioning, there should be some automatic way to promote this code to the production systems, but not only. You should also have a way to promote the code to the development, quality assurance, test, and so on. And this modality should be the same for all environments because you want to rehearse very well this promotion of code to the production system. So you will rehearse it into the dev, test, and quality assurance. So when you get to the production, you know that this process is a good one and reliable. Okay. First of all, I forgot to mention some details. I'll tell you some definitions. What we consider as a node or as a resource is a basic unit of computing you need when you deliver some application. It can be, this basic unit of computing can be virtual machine, it can be a container, or even a physical host. Okay, so this is about resources. What does a provisional manager does for those who don't know? Provisioning manager prepares some resource in order to be usable for the upper levels. So it can reserve some IP addresses in DHCP servers, it can provision the DNS, it can also create virtual machines or containers. It depends on what it needs to do. So it is an low-level orchestration for getting a resource up for the upper levels. And when we start this project, we had to look at a lot of components, and this was the most difficult part because, as you may know, in the open source world right now there is a huge fight over functionalities. There are a lot of companies, startup or not, or maybe well-established companies that are trying to push their software, and you have a lot of choices, and somehow it's hard to choose. This is the main point. So we, regarding the provisioning manager, we had to choose between Razor, between foreman and cobbler. What about configuration? A configuration manager is a software product which has the task of standardizing resource configurations and enforcing in an automated way to the systems. And here also there was a lot of alternatives. The same for workflow managers. The workflow manager is an orchestrator which can orchestrate across multiple resources. If the configuration manager ensures that the state of one node is the expected one, the workflow manager can orchestrate different steps across all these resources. So as you can see, we have a lot of choices to make. I put only the most important of them, not all. We started with a configuration manager because we have some, in our team we have some constraints. We have a team of sysadmins, and they are prolific with shell scripts, but not very good with generic programming languages. So most probably a DSL would be better for a sysadmin than Python or Ruby language. So this was one of the things that matters in our choice. So the easy adoption part. This is the easy adoption part. We looked also after tools that has enough maturity. It is old enough in the market. And also we took into consideration the fact that we should reuse this configuration manager component for our legacy systems. And we choose Puppet from Puppet Labs, the open source version of the Puppet. I believe Simon will say that this is a completely crap diagram, and I completely agree with him. If you attend the keynote from this morning. But I wanted to show in this diagram that we had to integrate with, we put some new components into our tools, and we should integrate with existing software components. And I believe there are some that you already heard about from Robert. Some new ones. The Artifactory is a target of builds, binary builds from Maven, let's say, or other build systems. F5 is our load balancer, and it has a good API for making changes. We are using VMware as a virtualization provider, and I'll told you a little bit about the others next. We also had to, since we are programming, we should look at coding best practices, and there are some particular best practices that I followed, me and my sysadmin teams, when we developed the Puppet code. And these are the data code separation. Puppet has a hierarchical database called Hiera, where you can store the configuration data. So in this way you can split between configuration code and configuration data. We also have a way we need to keep the code in the version control. And this one and the development workflow we choose conduct us to R10K, which automatize the gathering of code on the Puppet master from the Git. We are looking at unit and acceptance testing. It is completely possible right now to unit test your Puppet, your configuration management code with Puppet RSpec, and you can also do acceptance testing with server spec, which is acceptance testing framework for servers. It is not tied up anyway to a specific configuration management product. Okay, now I would like to have a short survey with you. How many? Please raise your hand if you have any system administration experience. Okay. Please keep your hand up if you have more than 5 years of system administration experience. Okay, so not too many. The idea is that in the early days of the system administration, the system admins tend to care about their systems. They put familiar names on it. They know everything about what is configured, where is it configured, what application runs on top of the servers, and so on. This was, let's say, you can say, well, what is wrong with this? It's not wrong, but it does not scale, and I will tell you why. There is a theory by a guy named Dunbar, which tells us that the number of social interactions that people can handle is limited at, in the average, for the average people, at 150 social interactions. You can, some can do more, some can do less. Of course, the level of social interactions is not the same for all the interactions you have. But what is really interesting in this fact is that also the human-machine interactions are in this number. So if you manage 100 systems, you will not have too many slots for interacting with other people. Okay, so this is also true for devices. If you know how to handle mobiles, you have a lot of gadgets around you. You will lose some slots from the social interactions with the humans. And if in the early days of system administration, the number of systems that system admins should manage was something intense, in number of tens. Right now, the economics of the business requires hundreds or in some cases even thousands of nodes to be managed by a sysadmin. And this is hard. And that's why we need to change the way we are thinking about the systems and treat the systems not as pets, as we used to do, but as kettles. And that's why I put these slides here. Instead of knowing exactly what a node does, we should know what a set of nodes are doing, because in this way we can reduce the number of slots we are using in our heads, okay, for social interactions. And we defined the node breed, and we used some abstractions of our tools, of the configuration manager, of the provisioning manager, and so on. We use some abstractions of these tools to define this breed. And in our case, the breed is given by the Puppet role, by the stage, which is actually a tag in environment. Okay, or environment, stage or environment, and by the compute attributes. How many CPUs does the node have? How much RAM? What is the disk space, and so on. That's why we need to tag everything. So instead of relying on host names doesn't matter anymore. We are not relying on host names, but we are relying on tags. So we are tagging our hosts, and everything we are doing based on tags. All the workflow steps are followed using the tags. Even we define actually two types of tags. These are the identification tags, which tell us about what project we are using this node in, what is the version of the project we are using, and so on. These are the identification tags, and the status tags, which tell us in each state the node is in during the workflow. This also allows us to have some security based on tags. The identification tags allow us to give access to the nodes and to the jobs for the nodes based on tags. The next idea after the tags was to build node herds or node pools, if you like. So we bring together nodes that have the same capability, and we are pre-provisioning them with the technology needed. In our case, until now we only automated Java-based application, JBoss and jar applications, and we are pre-provisioning this in order to gain some speed in the deployment. Of course, we did some glue code in order to put all these things together, and we use for this several languages. Ruby, because Puppet is written in Ruby. Python for big IP control API, and Bash for some orchestration. Regarding the scaling of the infrastructure, we started from the beginning with for the production. I mean, we started with a scale-out infrastructure. We have 7 nodes for foreman and puppet. We distributed all the components on these 7 nodes, and the setup was completely automatized by one of my colleagues. And right now we can spawn an entire automation infrastructure under 1 hour. We used the foreman installer named T.A.K.E, which is a Puppet-based installer, and it is very good. What's next? We are intending to do some things in the future as well. We will sponsor the rundeck development for integration with Git and for some encryption of sensitive options. We'll try to evaluate network orchestration capabilities. We will try to deal with containers because it's a hot topic and most probably will give us some advantages. And we will also look better at the acceptance testing with Beaker, which is a Puppet framework. If you have any questions regarding this, if not, we can start with the demo.
Sorry. What we are trying to show you here is what we want to do. For example, a short demo about how to deploy a change in the automatically. The idea is to show you what the pipeline runs, how the pipeline runs, and how do we propagate this change from developer IDE, or in my case will be the editor, to production, to staging. Just a second, because I want to resolve some stuff. I need to connect to Office.
We are going to show you a little bit the automatic deployment process and also the tools. We'll show you a little bit the provisioning manager, which is very well integrated with Puppet. It is serving also the dashboard for Puppet. We are going to show you the rundeck, and I believe Robert will show you the TeamCity.
Okay, what we are going to show here, it's an application, which the one which was subject to the proof of concept. The application really doesn't matter. It's for our case, it's a backend system which allows to send push notifications to our mobile users. It doesn't really matter. I want to show you a small change and reflect it back in the interface. Here I will try to modify, for example, this title here. So the first stuff I will try to clone the code from the repository. As I told you, we are using Stash. I will bring this code locally from our instance of Atlassian Stash. I will open this inside, and I will try to look for a file. The one is called header.html. In this case, I will put, for example, my take. I will save this. I will try to commit. git push back to the repository. Okay, I send back to the Stash has a nice interface here, which allows us to actually see the commits. Hello, I take here. At that moment, we will wait for our continuous integration server here to kick in and actually detect the change. And we'll start to build. What will actually happen, it will prepare the binary. This binary will be deployed to Artifactory. And at the end, this will go automatically to spawn a new instance of two or three servers. I don't know how many. Four servers. Okay, 4 servers. These 4 servers will actually be created from the pool that Virgil told you, and after that it will try to deploy the app, raise it, and we'll try to access it.
And also publishing to the big IP.
Okay. The idea is that we are going to wait a little bit. Meanwhile, we will try to explain what's going on. So now the continuous integration server detected the change. It started to clone the content of the repository. It, as you know, the continuous integration change actually has the role to be the independent source of truth. Actually, here integrating the work of all developers and actually testing it in an environment which is not at their fingertips. This is what's happening here inside. As I told you, the first step would be to build the application. After the compilation is fairly quick. The idea is now it try to publish the artifacts inside the Artifactory, which is the repository of binaries. And now actually what it did, it tries to connect to rundeck, which is the orchestration engine, and run a job with a certain parameters which tell rundeck what to do.
Mm-hmm.
If you want to
rundeck has a very good and comprehensive API, REST API, and this was chosen by us to all let's say, to offer a standard interface to the development teams. So this is a good thing about rundeck. It has a good and stable API. Let's see if here I can show you a little bit the rundeck interface. Just a moment. So the rundeck interface is organized in projects. You can granularly give access based on projects. The projects can define jobs, which can be can have several steps, can reference other jobs and so on. I will show you the application of this job to understand a little bit about the complexity of a job. So it referenced other jobs which did some things for in order to automate the entire process. Okay, I don't know if it's really relevant, but the idea is you can write these steps. Let's take you can write any of these steps in a interpreted language. Let's take this one as an example.
Where do you define the variables from the steps? For example, job project.
These are the options. You can define. It has a nice in the interface. You can define the options, and you can also validate the options. You have several ways to validate.
Some of the you define variables inside the job, but when you go, you can push variables through the APIs.
Yeah.
rundeck has a REST API. We actually calling the API to start a job from TeamCity. Actually, we have a build step which does only this, just to start up the job, and then waits, and actually because it's not it does not block, you poll for the changes in rundeck to see if the job actually finished. Because depending on the size of the nodes, the complexity of the jobs and so on, this can take a while. And you need to actually poll for the change and see if it's finished, for example.
So you also push the variable values through the rundeck API?
Some of them, yes. For example, app version, the path to Artifactory, binary, some environment settings. For example, you want to deploy to UAT, maybe you want to go to production, you specify this there. And the last step would be to have a separate job inside TeamCity, which you run manually or automatically if you feel like it, and you just press when you are ready to deploy that version inside the production, for example.
As you can see, these are the options of the job, and you also have layers of node filter, so you can choose to provision based on, as I said, based on text. So in some cases we define the state with these tags, and that's why we can choose dynamically the nodes during the workflow. The tags are changing during the workflow. The jobs are changing the tags when the node reaches some conditions.
The idea is not to tie to the machine names,
sure.
And you want to give them the roles, for example, web server, web application server, or maybe just a plain, I don't know, node to Redis or something like this, and you target this with inside your nodes with this.
As you can see, this job can call in another job, and
in our case, for example, this big IP, as Virgil told you, is central hardware that we are using. Is very good at treating large number of requests, and it's actually we invested a lot in this infrastructure previously. Actually, one of the reasons that we wanted to go inside the company, it was because we had a lot of infrastructure from the past. For example, we invested a lot in VMware. We have, as any operator, multiple sites for disaster recovery. Also, we have very strict law regarding the data accessibility, personal data accessibility. Are not allowed, for example, to publish on clouds, external clouds or something like this. And the idea was to find the right proportions of all these tools which fit together with existing investments. For example, in our case, VMware, Big IP, which is very good at what it does, but it's not. You don't find it. I don't know, very easily. You cannot find the recipes, for example, for Puppet to do what we were trying to do. For example, Big IP has a certain methodology of how it handles nodes, rules, virtual servers, and so on. And you want this to control through the API. And this type of integration we actually did through gluing code between the.
Okay. In this case, rundeck takes the list of hosts and their tags from the provisioning system, from the foreman, by running REST API. And what is interesting is that here we filtered the list of nodes, since this project should not see all the nodes that are available in the provisioning system, but only the nodes that are in the state prepared, so can be used for deployment, or the nodes that are already deployed with this project, for this project. Yeah, we'll go also with the activity tab, and here we see this that is running right now. It was started by TeamCity. Excuse the step failed is something normal. It was the only way to construct this workflow, so it's not wrong. It's good to be there. Anyway, it is not a step that is failing the entire workflow. It's recovering. Okay. So we can see that it started to do something. We can also look at the output. Okay, so it's running on the host. It started to lock servers for deployment, because if you have the idea is that you have a shared pool of nodes, you need to select them before starting to do the job, because they need to be yours, not You
If
should not
another
contend with
build-
with other project. Which
If
is
another
also-
build kicks in and they want to actually deploy, they need the nodes from the same pool, and you need to, let's say, somehow reserve for your own use. And we do this incrementally, meaning like it tries to lock, like a optimistic locking if you, from the programming, and after it took this, it actually going to do all the stuff only on those nodes as well.
Okay. Let me show you the provisioning interface. Sorry. So for this one. This is not the production system. Just to be sure.
So you have only one chance to enter the password.
You'll be kicked out. No, sorry.
You'll show your password in public.
Okay. This is our provisioning systems. As you can see, it's not looking very well on this display, but as you can see, there are a lot of nodes in different states. So,
What it actually does, it prepares a virtual machine with a certain configuration based on from ground. I mean, from bare. It's not bare metal; it's bare virtual. Let's say in this case, it actually installs a version of CentOS on it. It actually configures the operating system with the settings that they want in the sysadmin. For example, they can put monitoring tools or whatever they feel, or configuration settings for the whole box or something like this. And this system also takes into account, for example, what type of nodes. If you're familiar with deployment in cloud, you have configuration types of instances that you can select. This type of instances can be configured in this host, and this will take from vCenter, VMware vCenter, which holds the whole resources, and will prepare machines based on this configuration that you specify here.
yeah, here you can see the output of a Puppet run. It was a Puppet run several hours ago, and this is how it is looking like. Because the foreman has a good integration with Puppet, it can gather the reports and facts from the Puppet. So let's see how it's doing right now. If we advance with the job.
We have 2 times extra time.
Yeah, according to me. Yeah, right now it is deploying the application, the JBoss application.
If you have
Okay,
any questions
good.
meantime, we'd be happy to answer. Maybe
So-
show something else.
So in 10 minutes it provisions the VM, it installs the middleware and the application, right?
Yes.
Yeah, but this is being done asynchronously because we have the pools and we can do it beforehand. So we have some jobs that are in another project, in another rundeck project. We have some jobs that are raising the pools to fit the established limit, and also decommission the unneeded servers, the ones that are. Okay, sure.
A question for beforehand for the Artifactory tagging. Is this a process which is synchronously or asynchronous? Is it marked as a critical step, the tagging and the I understand that the Artifactory is just the binary is being committed for source control, yeah?
Yeah.
But since they are not source, is this process synchronously, so you have to wait for this to finish, or is it just starting?
This is the job of TeamCity. TeamCity has an integration with Artifactory, and
Okay.
it has on step configuration has an option to release to Artifactory, to publish the binary that it compiles and builds to Artifactory. And this is you indicate to. Just a second, if I. For example, here there is a plugin which we use. Artifactory has support for TeamCity, and actually what it does, you indicate in the server, and you configure prior the integration, actually authentication, all this stuff. You have a target repository where the, let's say, the release artifacts will go, and if you use snapshots, for example, you will have a separate.
Yeah, this was pretty clear. The question was
Okay.
just if this is synchronous test, so you wait for it to finish.
Yes,
or,
yes.
Yeah,
This
so
one
it's-
runs as asynchronous during the build.
So it's
Af-
synchronous, you wait for it.
Yeah.
It's not just
Only the provisioning, the part of the deployment that the next step will be done asynchronously.
Okay, thanks.
Yeah, it's taking more than used to. Okay, now it's ready. Now it's finished. Of course, in the demo mode, already it's taking a lot.
So the result here would be that
Thank you for waiting.
I don't know. What can I show you here? It's also what we in the build. For example, here at the end, for example, if you want to check the individual machines that were used, we have here also the name of the nodes which were deployed, because you maybe want to, I don't know, check them, although we do not want to allow people to go and enter the individual nodes.
But
Anyway, if you somehow need to know on which node the application was provisioned, this is the output, and to remain in TeamCity as a log, an audit log for what happened. This is pretty much all the presentation that we had. Feel free to ask us any questions, and if you want to discuss a little bit more, we'll be hanging out in the open space, and you can try to reach us with anything that you want to know. So, thank you.